Hello friends, I am Dr. Asmat Fatima and I am back again with another video, and today's video is all about the different types of files that we use while doing our root canal treatment. So by the thumbnail only you must be wondering, there are so many choices, so many different types of choices, and we don't know which file system should we use. Which file system is better than the other one? So we all the dental practitioners, all the fresh beginners, they are confused by the too many choices which are available in the market. So let us see one by one what are those types of files and which file is better for us. So the biggest question is that which file system should be used while doing the root canal treatment. This question, this doubt is, I think, one of the biggest doubt with all the dental practitioners who are practicing root canal treatment, who are practicing endodontics, because there are a variety of different files available in the market, and everyone claims, all the manufacturers, they claim that their file system is better than the other one. So we'll see all about the different files. So there is no such answer that which file system should you use, because it totally depends on the type of case which you are doing. It also depends on the endodontist preference, the endodontist methodology, which method he likes to use, step back or crown down, okay, or any hybrid technique. So there is no perfect single answer to this question that which file system is better. It all depends on the practitioner's capability, practitioner's preference, and upon the different types of cases. Okay, so this is a picture of a file, and there are basically three parts in a file. The first one is the handle, then there are some sort of lines which you can see here. So these are known as measuring lines. It denotes the length of the file. So if there are two black lines here, that means the length of the file is of 21 mm, and if there are four measuring lines, then the length of the file is 25 mm. Got it? Then the next is the active part. This one is the active part of the file. Okay, it consists of the blades, and here it is the tip of the file. It is also known as penetration guides. Now there are different types of files available in the market. Some are manual endodontic files, some are rotary endodontic files. Okay, so earlier, when there was no rotary, when there was no endomotor, all the practitioners, they used to follow the manual method for root canal treatment. But this method takes a lot of time, a lot of effort, and the preparation is not up to the mark only with manual files. Then with the advancement in the technology, and the endomotor came into existence, and then nowadays a lot of people, they are using the rotary endodontic files. So among the manual files, the first file is the K file, and these are the most commonly used type of files for root canal procedures. These files, they have an active cutting part of 16 mm, and they have a constant taper of 2%. Now again, constant taper of 2% means after every 1 mm increase of the file, there is an increase in diameter by 0.02 millimeters. Okay, after every 1 mm, the diameter of the file is increasing by 0.02 mm. Suppose if the taper is 4%, then after every 1 mm increase in the file, the length of the file, the diameter will increase by 0.04 mm. This is 2%, this is 4%. Similarly, in 6%, what will happen? There will be a constant increase in diameter of 0.06 mm after every 1 millimeter increase in the length. Got it? This is very easy. Now the next file among the manual file system is the C+ files. These are also known as root canal exploration files. Okay, and they are available in three lengths, that is 18 mm, 21 mm, and 25 mm. And these files, see, this stands for catheterization. That means whenever you are unable to find your root canal orifice, okay, sometimes there is calcification and your normal K file is not able to penetrate inside the root canal orifice, then the C files comes for rescue. The same is the case with C pilot files also. So it is manufactured by VDW company. So these are the special endodontic files, and they are particularly used for sinus and calcified canals. They are also available in 3 lengths, that is 19 mm, 21 mm and 25 mm. And they have a inactive tip. The tip does not cut anything. And they have also an intermediate size of 12.5. Okay, so these are for calcified canals. Then there is H file, which is also known as headstrong files. So it has a helicoidal shape and they cut only in one direction. That means the direction of pulling, that means the direction of retraction. Okay, because the flutes, they have a positive inclination. Okay, so they have this type of shape. This H file is almost different from K files. Okay, so these have this type of shape and they only cut in one direction when you pull it, when in the case of retraction. The earlier files that we were using, like the manual K files, H files, C plus files, they were all made with stainless steel. Now with the advancement in technology, the niti systems came into existence, and the niti instruments, they have two unique properties. One is the shape memory and another one is the super elasticity. And one of the biggest advantages of niti instruments is that while doing the root canal preparation, the files, they always remain centered within the canal, so there are very few chances of zipping or perforation or transportation. Then another advantage is greater flexibility, greater flexural strength, and they can easily be used in curved canals. What happened with the manual K files is that as the number of the file increases, the flexibility used to decrease. Okay, the stiffness property increases. So whenever these hand K files, the larger number hand K files, when they were used in curved canals, there were a lot of chances of instrument separation. Why? Because the instrument was not flexible, it was very stiff. This is the advantage with the niti instruments, that these niti instruments, they are very much flexible and they can easily be used in curved and narrow canals. And also there are reduced chances of instrument fracture within the canal. That means the cyclic fatigue resistance of these files, the niti instruments, that they are very good in terms of your manual K files or hand files. So in the niti instruments also, we have our hand niti instruments, that is the K file HyFlex. They are also available in the same sizes and colors which were available with the K files, that is white denotes number 15, yellow is number 20, red is number 25, blue is number 30, green is 35 and black is number 40. Also we have our hand Protaper files, which are also made of niti, but these files, they are not that much flexible as compared to the your Protaper rotary files. Okay, though the Protaper hand files, they are somewhat stiffer, they are not that much flexible. Then we are coming on to the niti rotary files. So these files, they are very less time consuming and there is a very less amount of effort needed while doing the root canal treatment if you're using these files. And also the number of instruments is reduced to almost 3 to 5 instruments for the entire root canal procedure, which takes less chairside time. So these are the better advantages of the niti rotary files. Let us have a look about the generations of rotary shaping files. So the first generation came in 1998, and all these file systems, what they have a passive cutting design. That means the cutting efficiency of these files, they were not that much good. Okay, and this first generation system included files like Lightspeed, System GT, that means greater taper, and Quantic. Then in 2001, the second generation of files came with active cutting design. That means the cutting efficiency was better than the first generation files. These files included the most famous Protaper universal files, which is still used today, the Hero Shaper files, and M2. these file systems, they have a variable taper. Okay, now constant taper, we discussed that all the hand files, they were having a constant taper. And in variable taper, that means ki suppose you are using a fixed taper file. Okay, the fixed taper files, they have a constant angle of increasing diameter along the active portion of the file. Okay, so at every 1 millimeter increase in the length of the file, the diameter is increasing at a constant diameter. Okay, but with the variable file systems, the variably tapered files, they have a different tapers of increasing and decreasing angles, okay, along the whole portion of the file. Somewhere the taper is more, somewhere the taper is less. That means whenever at wherever portion you need that perfect amount of taper, you will get that taper in that. Okay, so this is the example of variable taper. That means the files, the diameter is not constant. At some point the diameter is decreased, and at another point the diameter of the file is increased. So these second generations files, they have a variable taper, they have an active cutting blades, and they used fewer instruments to prepare the canal. Then third generation came in 2008, and there was a change in metallurgy of these files. The heat treated files came into existence, and the examples of heat treated files are twisted files, Profile GT Series X, and HyFlex CM. This file system, they had reduced cyclic fatigue, they had heating and cooling methods, and there were less chances of file instruments or separation. Then in fourth generation, there was an introduction of reciprocating files. The reciprocation thing came into existence, and the examples of these file systems were reciproc, liberator, and self-adjusting file. And they were having bidirectional movement. That means they rotated in clockwise motion also and anti-clockwise motion also, and there was a single file concept with these type of files. That means use and throw. In 2013, fifth generation files came with an offset design feature. That means the center of the mass of these files, that was not along the axis of rotation, it was off the axis. And that means that at one point of time, not all the parts of the file were touching the dentinal walls. So there was less amount of contact, and there was less degree of taper lock. So these files, they were having less chances of instrument separation within the canal. Now the most important quality of your endodontic instrument is flexibility. Okay, because in curved canals you need flexibility, in narrow canals you need flexibility. If your instrument is flexible, it will not fracture at any point inside the root canal. So you have to test your instrument to determine its stiffness. That means greater the rigidity of the instrument, there will be increased number of chances of breakage or failure and other complications like perforations and ledge and zip. So let us discuss first about the Protaper files. These are the most commonly used files among all the dental practitioners. So these files, they have different these file system, they have different types of files. So we have SX. That means SX is the orifice opener. This one is the orifice opener, and you will see there is no colored band over SX. Okay, so your SX is your orifice opener. Then you have shaping file S1 and S2. Okay, so S1 is having a purple band and S2 is having a white band. Then you have F1. F1 is the finishing files. There are 5 types of finishing files: F1, F2, F3, F4, and F5. F1 is yellow, then F2 is red, F3 is blue, F4 is it is having 2 black marks, and F5 is also having 2 yellow marks. Now let us start with the SX file, which is also known as shaping file X. So this file exhibits 9 increasingly larger tapers, okay, ranging from 3.5% to 19% between D1 and D9. I've already told you the concept of variable taper is these Protaper files, they are a variable taper system. Okay, now variable taper is something like some point of time there is increasing tapers, along the other portion of the files there is decreasing taper. So here in SX, between diameter D1 and D9, that means D1 denotes the tip diameter at the diameter at your tip. So at D1 and D9 position, the taper, it increases with the range of 3.5 to 19%, whereas between D10 and D14 part, they have a fixed taper of 2%. So this is the example of variable taper files. That means the taper is not same throughout the length of the file. It varies. Somewhere it increases, somewhere it decreases, and somewhere it is constant. So you can see here between D10 and D14 there is a fixed taper of 2%. Now let us see the shaping files S1 and S2. So the tip diameter of S1 is 0.17 millimeters and the tip diameter of S2 is 0.20 millimeters. That means this S2, it corresponds to file number 20 K file. Okay, so the shaping file number 1, it is basically designed to prepare the coronal 1/3 of the canal, and S2, it enlarges the middle third of the canal. That means this S1, it has larger taper. See, the increasing taper is at this region, that means in the coronal area. That is why it contacts the dentinal wall and it cuts the dentinal wall. Okay, so it is generally used for the preparation of coronal 1/3. And this S2, it has a large amount of taper in the middle third also, है ना? That means it prepares the coronal as well as middle third. Now let us start discussing about F1, that is the finishing files. So this F1, it has a tip diameter of 0.20, F2 is having a tip diameter of 0.25, and F3 is having a tip diameter of 0.30, and it has a taper of 7%, 8% and 9%. So between D0 and D3, the F1, F2 and F3, they have a fixed taper of 7, 8 and 9%. Only between D0 and D3. After that, the taper varies. From D4 to D14, each instrument has increasing cross-sectional dimensions, but importantly, over this same length, each instrument has a decreasing percentage taper. That means these finishing files, they are mainly used to prepare the apical 1/3. So these have larger diameters in the apical area, while as you move towards the coronal part, the taper decreases. So it has a decreasing percentage taper from D4 to D14. So decreasing percentage taper, what is the role of this decreasing percentage taper? Why the manufacturer has given this thing? Because it serves to improve the flexibility of these files, and this feature will improve safety by reducing the potential of these files for taper lock in the canal. Now these Protaper, this is also known as progressively tapered nickel titanium instruments. They are designed to instrument the difficult, highly calcified and severely curved canals. And the advantages of variable taper is that it prevents the screw-in effect. There will be less taper lock within the canal. Okay, allows increased apical tapers. That means with the finishing files, the taper is more in the apical third area and it will clean more of the apical third. And with the shaping files, the taper is more in the coronal area, and it allows excellent shaping with only few instruments. So the manufacturer, they have recommended some speed and torque, which is which you should always use while using these type of files. That is, if you're using Protaper Gold S1 and SX, then your speed with all these instruments should be 300 rpm with every file. That means SX, S1, S2, F1, F2, F3, F4 and F5. The speed is constant, that is of 300 rpm, while torque is 5.10 for SX and S1, 1.50 for S2 and F1, and 3.10 for F2, F3, F4 and F5. Another file system is of NeoEndo, that means the NeoEndo Flex files. They also utilize a proprietary heat treatment. In Protaper Gold also there was a it was also a heat treated file. Okay, that means the name is gold, it comes from the heat treatment. The color, it comes from the heat treatment. That's why it has given the name of Protaper Gold. And this NeoEndo Flex files also, they utilize a heat treatment methodology, and they have greater flexibility and a non-cutting safety tip. These files should be used at a speed of 350 rpm and torque of 1.5. So with the NeoEndo Flex files, first of all you have to start with your number k, smaller number k files, and this is a rule that with every rotary file system you're using, you have to initially use your manual k files for making the glide path preparation. Okay, so always use your smaller k files, that means 6, 8, 10 and 15 k files for making the glide path. Then only you have to proceed with your rotary files. So here also in NeoEndo Flex file system, you have to use your number 15k file, and then you have to use their orifice opener. This one is the orifice opener, and there is no colored band present over the orifice opener. Okay, then you can use your glide path files. That means this file system, it comes with a glide path file of its own. Otherwise you can use the glide path files of Protaper, the Dentsply, okay, the Pro gliders. Okay, but this NeoEndo file system, it has its own glide path file which has a tip diameter of 17 and it has a constant taper of 4%. Then there are several files in this system. So these are the two files which are used for narrow canals. That means 20 number file having a 4% taper and 25 number file having a 4% taper. So these file systems, they are used for narrow canals. If your canal is medium in size, then you can use your number 26% or number 34%. Okay, and if it is a very wide canal, like in case of palatal canals or your distals, then you can go on for 25.6% or 35.4%. Okay, see this 24%, that means it is having only a single yellow band. In 26% there is two yellow band. This is the difference. Here also in 25.4% there is only a single red band, and in 25.6% there are two red bands. Got it? So this file system, it is almost, it can be used almost for all types of canals, narrow, medium or wide canals. So they have given a lot of files, and whatever file suits you, whatever file suits your case, you can use that file. So it is also a very good file system. Then another file from NeoEndo company is NeoEndo Ultimo Flex files. So these files also, they have an orifice opener. Then there are initial shaping files. That means the NeoEndo Ultimo files are there, having a 10.4% and 15.5% taper. Then these files consist of small, medium and large files for different types of canals. Here you can use 25.4% or 26%. If your canal is medium, then you can use your 34% or 25.6%. And if your canal is large, then you can use your 35.4% or 36%. This means that your tip diameter of the file is 35 and the taper is 4%. And 36% means the tip diameter is 30 and your taper is 6%. And these files, they are used at a speed of 200 rpm and a torque of 1.5. Another one from NeoEndo is NeoEndo S. So these are the rotary files. They have a special S-shaped cross section, and the perfect advantage of this S-shaped cross section is that it allows minimal radial wall contact, so the amount of stress on the file will be reduced and there will be less chances of file breakage. So this file, after using your K file, you have to use your NeoEndo S glide path file that is having a 17 and 4% taper. Then these are also for narrow, medium and large canals. So for narrow canals, you can either use your 24% or 26%. For medium, you can use 25.4% or 25.6%. And for large canals, you can use 34% or 36%. Then another brand is Colteen. You can use their HyFlex file system. So HyFlex file system is having more than one system. It has HyFlex EDM, which is a one file system. Then HyFlex CM is there. CM stands for control memory. EDM stands for electric discharge machining. Then HyFlex NT is there, and then HyFlex GPF is there, glide path rotary. So if we talk about HyFlex EDM, it is a single file system. So only one file is used to prepare the entire canal. This file, it has the manufacturers, they claim that it has unmatched fracture resistance. It has a variable cross section, and the cutting efficiencies of these files is very good. They are extremely flexible. And if we see about the systems, how to use these files, so first of all you have to use an orifice opener, then you have to use your hand files for making the glide path, or you can use your 10.5% glide path file. Then this only single file is used for shaping the canal, which is 25 HyFlex 1 file. And if you want to prepare your canal furthermore, you can use finishing files, that means files of 44%, 53% taper, or 62% taper. Okay, but usually it is a single file system, so you can stop your preparation if your canal is not that much wide enough. Then next one is the HyFlex CM files, that means the control memory files. So with these files there is one advantage, that there is no rebound and it is extremely flexible file. So it will take the shape of the canal, and if you will bring it out, it will not try to straighten itself within the canal. This is the perfect advantage of this file. It will take the shape of your curved canal, and if you will sterilize it again, then after autoclaving it will assume its normal shape, that means a straight shape. So this system, it has, first of all you have to use your number 10, 15 and 20K files. Then there is orifice opener. Then they have 24% tapered file, 26% and 25% tapered file. So you can use these files in this sequence. So one of the best advantage is that it has a controlled memory, that means assuming the shape of the canal, and it will not try to straighten itself, so there will be very less chances of like perforation. And also it has extreme flexibility, so it will be very much flexible within the canal, and there will be less chances of breakage of these type of files. Another file system is the NT file system. So the NT Rainbow S files, these are very much like popular nowadays in the market, and these files are nano coated files. So they're also made with advanced heat treated methodology, and they're also nano coated. So they are available in 4% and 6% taper. So these taper design is easy to understand, and then they are extremely flexible because of the advanced heat treatment. They are durable. Why? Because they are made up with unique nanocarbon coating, which offers high cyclic fatigue resistance. And they have a non-cutting safety working tip, so that you can avoid ledge formation. So that's all for today's video. There are different types of files, so it all totally depends on the operator, what type of system he wishes to use. Okay, if you want flexibility, you can use all these type of files which is made with advanced heat treatment, or if you just want like your file to be having a greater cutting efficiency, then you can use the Protaper ones. Okay, so these are all the file systems. It depends on you which one you would like to use, and kindly comment below which file system you prefer to use mostly in all the cases. And if you liked my content, please hit the like button, and please also hit the subscribe button. I need some subscribers. Please follow me. Bye. Thank you.